So now we're going to look at an example of a question that might use our knowledge from the family of functions and members of the family. So this one says, determine an equation for the family of quartic functions represented by the graph and determine the equation of this member of the family. So the first thing that we need to point out, or that you might notice, is that it says quartic functions. And quartic just means that it's to the degree of 4. So this has one root here, and one root here, except we know that if we add up all of the x's, then the degree should all add up to 4 because it's a quartic function. So we know that it's to determine the equation of the member, of the family of quartic functions. Then it means that we're going to have a different a value for every one of these. So first thing that we're going to look at are just simply the roots. So we've got a root here at x equals -3. And then it crosses the x-axis again right over here, and this root is x is equal to 2. And then it goes down and it comes back up right here, and this last root is x is equal to 5. So right now this is all that we have. We've got f of x, which is equal to y. And that the graph of this, it's going to be some sort of value of a. We don't know it yet because it's a family, so we don't have to say what it is. And then in standard form, it's going to be, well, this one in factor form would be x plus 3. There's x plus 3. Then we've got an x, and the root is 5, so it's going to be x minus 5. And then our last root is at x equals 2, so then you can figure out that one's going to be x minus 2. But there's one thing that we're missing from this, and if you see, this is order 1. This root's order 1, and this one's also order 1. So it means that if we were to draw this, technically it means that all of these would be passing through each other, because order 1 means that it will pass through. But we know that when something's order 2, it means that it'll bounce back. So let's take a look at these again. So this one right here, what order would this one likely be? Well, this one just passes straight through, so it's just going to be order 1. Then we look at this one, and this one doesn't pass through. It touches the x-axis and then it bounces back. So when we know that something bounces back when the root is order 2. And if I'm writing in all the orders, I guess I'll say this one is order 1. Hold on. This one is order 1. Just ignore that little thing on the side. And then we got this one here. This one also passes through, so this last root will be order 1 as well. So since this one's order 2, we just need a little exponent on the outside brackets of x minus 2 right here. We need an exponent to the power of 2. So now it is a quartic function because this is order 1, this is order 1, and this is 2. So if we add all of these up, then it'll be a degree 4. So yes, this is quartic function. So this is what we could say the family of functions. This is an equation for the family of functions. So this particular member, we need to figure out what this value of a would be. So in order to do that, it's actually very simple. All we're going to do is pick a point. So let's find a point. This point looks very easy. So we've got a y-intercept at -2. So the point, this, x is 0. So 0, and then our y value is -2. So again, this is our x, and this is our y. So now what we could do y, which is -2, plug that in, and then that will be equal to, and then if we plug in all of our x's as 0, because we're really just plugging in a point, and hold on, I forgot to write in our variable a equals a, and then bracket, and then we can write in all of our zeros. So 0 plus 3, and then this will be 0 minus 5, and then it'll be another 0 minus 2, and this one is squared. So then if we were to continue to do this, we get a equals 3 times -5 to the power of -2 squared. -2 will be equal to, well, this will be first, so it's going to be a times 3 times -5, and then -2 to the exponent of 2 is just 4, positive 4. negative 2 will be equal to, and then if we simplify this, we'll get negative 5 times 4 is negative 20. Negative 20 times 3 is negative 60. So it would be negative 60a. So now simply, all that we have to do to isolate for a is divide by negative 60, not a. Divide negative 60 by both sides. And that's weird. Why isn't that showing up? There we go. Negative 60. And then this is going to be 1 over 30 is equal to a. So if we wanted to write this as a function, then we could write it as this family, or this member of the family, would be f of x is equal to 1/30th, and then it would be x plus 3, x minus 5, and then x minus 2, and it bounces back, so it's to order 2. So now let's just double check our work. I'm going to bring out this calculator, and let's graph it, just to double check, to make sure that we did this right. So we've got y is equal to, and then we got 1 over 30. I'm going to put that in brackets though. 1 divided by 30. And then we've got x plus 3, bracket, x minus 5, bracket, and then x minus 2, minus 2, and this one's to the exponent of 2. So hopefully this should give us a graph that looks something like this. And there you go. You can see that this is correct because these two are the same.